welcome the guest of honor, Professor Gopal Gupta ji, by presenting him Tulsi Sapling as a token of love and respect. Please, sir. Please, students, give a big hand to welcome our honorable chief guest and guest of honor. Thank you, sir, for gracing this auspicious occasion with your presence. This conference at College of Engineering, Roorkee is an outstanding intellectual output of our Director General, Professor S.P. Gupta, a navigator of the flagship of knowledge. Now, I would like to invite him to present his welcome address to our reverend guests and valued audience. Please, sir.
YouTube पर आया सर अभी हमने एक बार देखा ना कि कैमरा हमने होल्ड करा था नहीं करा था।
Thank you.
लाइव चल रहा है कैसे आप
Honorable Chairman Shri J.C. Jain sir, Honorable Chief Guest Professor Nareem S. Chaudhary, Vice Chancellor, Uttarakhand Technical University, Honorable and Distinguished Guest of Honor, Professor Gopal Gupta, University of Texas at Dallas, USA, Honorable Shri Shriyanti, esteemed trustees of St. Roshanlal Trust, Roshanlal Nain Trust, honorable invited guests, my esteemed faculty colleagues, members of the press, and dear students. A very good morning and warm welcome to you all this morning to the inaugural function of the International Conference on Artificial Intelligence and Applications. Artificial intelligence is poised to change our lives, with intelligent machines enabling high-level cognitive processes like thinking, perceiving, learning, problem-solving, and decision-making, coupled with the advances in data collection and aggregation, analytics, and computer processing power. AI presents opportunities to complement and supplement human intelligence and enrich the way people live and work. It is in this perspective and to create awareness of and excitement among students who are the future, we are organizing this international conference. We are most indebted to our chairman, Shri J.C. Jain sir, who has always mentored and led us into exploring new initiatives and challenges for the sake of turning our students as future ready. We are grateful to him, our Vice Chairperson, Srimati Smita Jain, members of the Trust, the young and ability ingredient of their career. Jai, thank you.
Thank you, sir, for your welcome address. We are really very charmed by your influential words. Now I would like to upon stage a famed personality, Dr. Siddharth Jain, who is meticulous in a research field. Dr. Siddharth Jain, please. He is going to read out the report of this conference.
A very good afternoon to all of you, all the dignitaries, delegates, and your students. I, Dr. Siddharth Jain, Associate Professor in the Department of Mechanical Engineering and Organizing Secretary of this conference, welcome you all in the first IEEE Core International Conference on Artificial Intelligence and Applications. As artificial intelligence aims to create intelligent systems, it has become an essential part of the technology industry. With this background, the conference was planned almost a year ago with the aim of drawing recommendations related to key applications and research areas that have emerged for further research in this area. The focus of the conference would be on the worldwide research and development in the area of artificial intelligence, as stated by Professor S.P. Gupta. In this conference, we received participation of experts from different countries. About 10 speakers from worldwide universities and industries would address the gathering during the plenary and technical sessions of the conference and would cover the diversified research areas of artificial intelligence in engineering and technology. This conference includes the talk of Professor Gopal Gupta from University of Texas at Dallas, who will discuss on artificial intelligence, the road forward. Professor Kalyan Dale and Professor Eric Goodman would discuss on evolutionary computation and machine learning reinforce each other. Professor Nishal Verma from IIT Kanpur would deliver his talk on deep learning and its role in artificial intelligence. Dr. Hari Lal from ONGC will deliver his talk on AI in petroleum exploration. Other renowned dignitaries and experts in the field of artificial intelligence are Professor Devidas Kundu, Professor Jivanand Seshadrina, Professor Manoj Tripathi, Professor Sudeep Roy from IIT Roorkee, and they are discussing on the different aspects of artificial intelligence. The conference will provide a platform to discuss around 45 papers in 5 different technical sessions after peer review by AI experts. The conference received papers from IIT Roorkee, IIT Kanpur, IIT Delhi, Ecole des Technologies University, Quebec, Canada, Pantnagar University, ONGC, Gautam Buddha University, Thapar University, Dayalbagh Educational Institute, Dayalbagh, and other institutes of repute. I hope that the conference would present a big opportunity for delegates, faculty members, and for our students to share global experience in the field of artificial intelligence and will draw recommendations in the area of artificial intelligence which may help in drawing a roadmap for future. Thank you.
Thank you, Dr. Siddharth, for giving your valuable insight on the topic artificial intelligence and its application. Now I request all the dignitaries for the release of proceeding CD. Please, sir.
सर एटलीस्ट गूगल की जगह पे ना दोनों स्क्रीन पे IEEE की वो दिखा दो स्लाइड। नहीं
साइट बता
नहीं पता IEEE नहीं अपनी इसकी कॉन्फ्रेंस
बोर्ड की साइट है।
हाँ ये कुछ इंटरनेशनल कॉन्फ्रेंस का कोई पेज होता है।
The knowledge and experience of our engineer J.C. Jainji, Chairman College of Engineering Group, the man behind the success of this coveted institute. This institute has been successful in its mission all along the years under his expert guidance and has distinguished itself as a preeminent institution for technological studies. Now, it is entirely my pleasure and honor to invite our Honorable Chairman, Sir, Engineer J.C. Jain, a man of distinct vision and a fountain of knowledge, to convey the welcome speech to our lovely audience. Sir, please.
Professor Gupta-ji, Madam Gupta-ji, distinguished guests, faculty members and delegates. It's my absolute privilege to welcome each one of you here. The artificial intelligence is a subject of today. the entire world, including Government of India, is putting very special thrust on the applications of artificial intelligence. We know the growing fields of healthcare, agriculture productivity enhancement, education improvements, smart cities and infrastructure, and smart mobility are the subjects of today. Our government is taking very special efforts, and I'm sure a conference of this kind would make all of us enriched on this subject. It's an extremely rare opportunity when delegates like Professor Gupta, who has traveled all the way from US, is here with us. He is the third largest computing department in US. I'm sure we will get a lot from him. There are many more eminent professors, those who have traveled all the way from US and IITs and ITs. Such conference where dignitaries of this level are available, it's extremely rare, and I wish this conference to be a great success. I'm sure all of us are going to be impressed by this experience. Thank you so much.
Thank you very much, sir. Your thought-provoking address set a perfect platform for our college. It is my immense pleasure to invite our respected guest of honor, Eric Johnson Professor Dr. Gopal Gupta, University of Texas at Dallas. But before calling him behind the podium, I would request Dr. Brij Mohan Singh, Dean Academic and Organizing Secretary of the conference, to read out biodata of our honorable guest of honor, who is one of the mentors for education services. Please, Brij Mohan sir.
Thank you, ma'am. A warm good afternoon to all of you. It's my immense pleasure to introduce Professor Gopal Gupta, sir. Dr. Gopal Gupta is the Eric Johnson Professor and Department Head of the Computer Science Department at the University of Texas at Dallas. His areas of research interests are in artificial intelligence, automated reasoning, computational logic, machine learning, programming languages, and assistive technologies. He has published extensively in these areas. His group has also authored many software systems, several of which are publicly available. His research work has also resulted in commercial software systems that have formed the basis of two startup companies. He has won several Best Paper Awards as well as the ICLP 2016 Most Influential Paper Award. He obtained his MS and PhD degrees from UNC Chapel Hill in 1987 and 1991 respectively, and his BTech in Computer Science from IIT Kanpur, India in 1985. So, may I request you to deliver your address.
Great privilege to be here. I really want to thank Professor Satyaji and Mr. Jain, both Mr. J.C. Jain and Shriyans Jain for their great hospitality. It really is wonderful to be here. So as you know, I delivered a tutorial yesterday and I'm really impressed by the number of students who came. I think something like 150, more than 150 students. All of you came over there. Many of you are asking wonderful questions, so I was really impressed. Also impressed by the wonderful facilities that are over here and the wonderful setup. This is really a great conference, and really kudos to Dr. Satya Gupta and again, Dr. Mr. Jain, both Mr. J.C. Jain and Shriyans Jain for having this vision to actually start a conference in artificial intelligence, which is getting a lot of attention these days. So I want to give a message to the students, and then also I'll keep my talk brief because if I speak more, it cuts into my time of giving my technical talk, which is going to come later. So the message to students, my message to you, the students, is that you should really strive hard. Strive hard and strive for excellence, and the future will be yours. You really have to work hard. To succeed, again, you really have to work hard. But the important thing is to enjoy that work. So what you will find is that if you study a subject really well, and you understand the subject well, then you really enjoy it. And you can also see ways of improving things, and that actually leads to research. So that was my own experience as a school student and as an undergraduate student. When I was a school student, maybe 5th grade or 6th grade, somebody gifted me a book that had biography of famous scientists, and Edison. And I was really inspired by that book, and I decided that I wanted to be a researcher, and I'm a researcher, and I pursued that dream. So even when I was an undergraduate, I knew I wanted to be a professor. So that's what I wanted to do as well, basically. Dream big and form your dreams now and pursue them with passion. So people ask me, I got my undergraduate degree in 1985, so you can guess my age, I'm in my mid-50s. People ask me, do professors retire in the USA, and am I going to retire? And I tell them that, well, one thing is that professors don't retire in the USA. They can work forever until they drop dead. But also, if I look at my job, so what is retirement? Retirement is that you have the freedom to do whatever you want to do, and you are doing something that you really like to do. And I'm doing both. So I'm really living my dream. I'm doing research and teaching, and I really love that. And since I'm a professor, I have 100% flexibility. So I'm already retired, so I don't have to retire actually. So with that, I hope that you will strive hard and you'll really dream big and make a big name for College of Engineering once you graduate from here. Thank you again very much for inviting me for
Thank you, sir, for your motivational words. Now, I would request Shri Shriyansh Jainji to give brief introduction of our chief guest, Dr. Narendra S. Chaudhary, Vice Chancellor, Uttarakhand Technical University, who has made all of us proud by his distinguished work in numerous capacities. Please, sir.
Good afternoon to one and all. Dr. Narendra S. Chaudhary, Vice Chancellor, Uttarakhand Technical University. He has been associated with IIT Indore since 2009 as a Professor of Computer Science and Engineering. Dr. Chaudhary has shouldered many senior level administrative positions in universities in India and abroad. He has completed his undergraduate, postgraduate and doctoral studies at IIT Mumbai. He is an established researcher in computer science and engineering with significant contributions to engineering education as institute developer and to professional societies. His significant research work contributions are in the areas of machine learning, network security, mobile computing, game AI, novel neural network models like binary neural nets and bidirectional nets, context-free grammar parsing, optimization, parallel algorithms, and graph isomorphism problem. Ladies and gentlemen, Dr. Chaudhary has supervised more than 44 doctoral and 80 master students and completed 8 R&D projects funded by DST, UGC, AICT and MHRD, etc. He has been a reviewer for DST and UGC projects. He has also contributed collaborative research work on other pilot projects on computing techniques and industry interaction funded by ST Engineering, DSTA and A-Star, etc. in Singapore. He has been keynote speaker in many conferences in the areas of soft computing, game AI, data management and information technology. He has more than 375 publications in international journals and conferences. He has been referee and reviewer for a number of premier conferences and journals including IEEE Transactions, Eurocomputing, etc. Dr. Chaudhary is fellow and recipient of Eminent Engineer Award, Amity Academic Excellence Award, Bharat Vidya Shilpagni Award. He was facilitated as Best Teacher in Engineering in National Education Leadership Awards. He is also recipient of Lifetime Achievement Award by National Institute of Cleanliness Education and Research. Ladies and gentlemen, I'd like all of you to put your hands together and welcome this eminent personality and give him a warm welcome.
Chairman of this group of institutions, College of Engineering, Engineer J.C. Jain, Managing Director of this group, Mr. Sriyan Jain, Professor S.P. Gupta, Director General of this group of institutes, our distinguished expert inviting and going to be the speaker who is going to talk about immediately after my address, Professor Gopal Gupta ji of University of Texas at Dallas. I suppose he is going to talk about AI, the road ahead. So naturally we will have a perspective of what is going to happen in this particular very important area. Major General O.P. Soni ji, Professor Shankar Devsarkar ji of Baba Saheb Ambedkar Technological University, Lodere, Maharashtra, Professor Pathak, Organizing Secretaries Brij Mohan Singh ji, and we also have as Organizing Secretary Siddharth Jain ji, who has already told us about briefly this conference. Distinguished faculty members of core group of institutes, inviting experts from IIT Roorkee and IIT Kanpur, and all participants. As such, from Uttarakhand Technological University, I would say that we have organized various conferences. Now when I say UTU has organized various conferences, UTU is an affiliating university, and we are happy to say that we have promoted many areas which are of technological importance by faculty development programs, conferences, conclaves. Some of the industry conclaves, they are very successful, and many other activities with the help of World Bank's Technology Education Quality Improvement Program or TEQ. I am happy to see that for this event as well, UTU has been supporting, of course to some extent, whatever extent is possible. This program is also supported by TEQ program through Uttarakhand Technological University. The program is very apt, and it has already been said. Lord Professor Gopal Gupta ji is going to talk about the road ahead of AI, and I am happy to see that on the tracks in the pamphlet I see there are 11 tracks, and in the 11 tracks lot of things are going to be talked about. The proceedings, I am sure, are already available, which have been just released in the form of CD, on which documentary papers will be available, I think already available, and we are going to discuss these concepts through whatever the researchers have already thought about and whatever are their proposals. I suppose the conferences like these connect all the researchers, and they form the beginning of the research career. I would like to advise that the paper paper presentations at such conferences should not stop at just publication in the proceedings of this conference, but this work should be extended, substantially revised, and finally reported in the archival journals. When I say archival journals, I would suggest, particularly for this particular area of computer science and engineering, either IEEE transactions or ECM transactions. Why I would say is because in Uttarakhand Technological University, a lot of brainstorming is being done about how the quality of research is to be maintained and it is to be uplifted. The research is not to be done just for the sake of research, but it should also be done for upliftment of the neighborhood in which we are living. In particular, I would say that the research, the conferences like this, as the international conferences, the concepts which are being discussed and are of importance at the international level should be adopted locally to our state, particularly Uttarakhand state. And our state has unique position. We do have a lot of natural resources. हमारे स्टेट में पहाड़ी इलाके भी बहुत है और पहाड़ी इलाकों में क्या इस तरीके के कॉन्फ्रेंसेस से हम पलायन को रोक सकते हैं। पलायन को अगर रोकना है तो हमें क्या चाहिए? हमें जो अपॉर्चुनिटीज क्रिएट करनी है, इस तरीके की अपॉर्चुनिटीज हमें आर्टिफिशियल इंटेलिजेंस से क्रिएट करनी है कि जहां पर कोई भी उसे परमानेंट कर सके। If we look at the history says that actually prominent conferences of artificial intelligence started getting organized since late 1950s, and lot of discussion has now taken place and archival material is available on artificial intelligence. One of the simplest definition of artificial intelligence says that AI is the set of technologies which improve whatever human intelligence is better at a particular point of time. So at a particular point of time, we have the computing technologies which do lot of good jobs, but human intelligence can do certain jobs better. Now, which are the jobs human beings can do better? In 1950s also it is playing the chess. Now, with lot of heuristics, lot of understanding of the techniques, we are able to say that computer programs which can beat human players are possible. If not beat, at least compete at the human intelligence. Now, in future, what is going to happen? Lot of robots we are seeing which mimic human intelligence. In future, what are the higher level thinking processes which human beings are still able to do much better? And can the AI, can the robots take up those things? Are the wide questions. If we look at the history of computing, again if it goes back, as a professor of computer science and engineering, I would still say that one of the turning points is the conceptual formulation of the notion of computation, which came in 19th century. It came by Alan Turing. The formulation of it came by Noam Chomsky in the form of formal languages. Another model came as a recursive function theoretic model in the European circle. In the Russian circle, there were other models, and these models tell us the limitations of theoretical limitations of the computing system. In AI development, we must be aware of this fact that diagonalization problem or a sales paradox kind of scenarios do happen. When we talk about the solutions in the most general sense, in computer science, one of the most popular problems is like this, that a student writes a program and probably he makes a mistake. At some time, there are infinite loops which are created, which get created. Can we have an automated system which will detect, which will examine the program which is written by the student along with the data on which it acts upon, and it will produce automatically a finite amount of time because wherever the program is going to terminate or not, the student's program is going to terminate or not, and such a kind of problem is unsolvable. So, popularly known in computer science as working problem of the machine, these have some implications in AI, and these are some wide thinking about the limitations that we talk about. Theoretically, of course, we know that there are only computable functions which can be represented by the machine, and these are quite theoretical things. But we must keep this theory in the mind when we talk about what AI can do and what AI cannot do. I am actually diverting a little bit from the kind of topics which are going to be discussed, and I am happy to see that contemporary issues are going to be discussed in 11 tracks in this conference. I suppose the discussions will be very fruitful, they will connect all of us, and most importantly, these discussions should help our state, Uttarakhand, for the development. So I would say that as researchers, please try to identify how we can apply these things to, as Honorable Chairman J.C. Jain sir has already said, that there are many areas in which we can apply this. Healthcare, particularly Ayurvedic health care. Smart cities, that our Honorable CM had just inaugurated few days back at Dehradun. Such kind of big projects. पहाड़ों के एरिया में हम 4 धाम कनेक्ट करने के लिए पहाड़ों की कटाई कर रहे हैं। रोड्स कनेक्ट करने के लिए और रोड्स पर किस तरीके से हम ट्रैफिक को स्मार्ट बना सकते हैं। बहुत सारे इश्यूज हैं। हमारी जैविक खेती हम किस तरीके से इम्प्रूव कर सकते हैं, ये भी टॉपिक है। तो आई वुड सजेस्ट दैट प्लीज ट्राई टू कनेक्ट the technological discussions on AI which are happening in this conference with these problems as well, and try to come up with the research proposals and the solution projects. My best wishes for the conference. Thank you. Jai Uttarakhand. Jai Hind.
Thank you, Honorable VC Sir, for your inspirational and encouraging words. Dear audience, we rarely get this kind of opportunity to listen to the words of a knowledgeable speaker. I am talking about Eric Johnson Professor, Dr. Gopal Gupta. I very humbly invite him on the stage for his keynote speech. Please, sir.
started, since I'm Department of Computer Science at the University of Texas, Dallas, I always have to tell you about the department and do some marketing for it, and hope that some of you will apply for graduate programs and join us as students. So brief history of the University of Texas, Dallas, where I'm a professor. It's a very young institution. So it was founded in 1969, so it's celebrating its 50th anniversary. So it's really not very old. As universities go, 50 years is really young, because the world's oldest universities are, for example, the oldest university is University of Bologna, which was founded in 1200 something AD. So 50 years is really young, and I know Icaia is 98, founded in 98, so it's also really young. But for being a young university, we have done really well. We are ranked number 21 in Times of London ranking of universities younger than 50, number 1 in US among universities younger than 50. We have more than 30,000 students. And actually, computer science is really valued there. It's the largest department with more than 4,500 students. And just like where we are a tech-heavy university focused on computing, engineering, technology, science, and management. The computer science department actually got started as soon as the university was founded. And today, in fact, we are the third largest, as Chairman Chen said, we're the third largest department in the United States. So 4,500 students is really large. 3,300 undergraduates, 1,100 master's students. A lot of these master's students are actually from India, about 800 of them. So again, I invite you to apply, and it's competitive, the admission is competitive, but I'm sure many of you are smart students and you will get admitted. We actually produce 1,000 graduates each year. The whole United States produces maybe 70,000 graduates in computer science. So we account for more than 1% of the output of the whole country, which is, I would say, quite amazing. We also have world-renowned faculty members who are very well world-renowned for their research. We do a lot of research as well, and a lot of funded research, about $8 to $9 million for doing various projects. And that actually, so in the United States, universities are ranked by almost every metric you can think of. One of them is research expenditure, how much money you bring from outside and how much money you spend on research. Based on that, we are ranked number 37, which is actually still pretty impressive. We're also ranked very high in things like what's called LinkedIn rankings. So LinkedIn knows, all of you are on LinkedIn, I'm sure, right? LinkedIn is the social network, Facebook for professionals, you can call it. So LinkedIn ranked universities a few years ago based on what percentage of alumni are working in top companies like Google, Amazon.com, and Facebook, and Apple, and all those. And we came in at number 21, so our graduates do really well. So another reason to come and do your graduate studies there. We're also ranked nationally very high in research in things like AI, number 14 in the nation in the US, number 6 in natural language processing, and number 6 in software engineering. So I hope that motivates you to at least consider applying for graduate school or getting your master's or PhD to UT Dallas. Okay, so let's come to the subject of artificial intelligence. So to look at the road forward, we have to look at the past as well. So what I'll try to do is to give you an overview of the whole field of artificial intelligence, going back 50 years, and then look into the future as to how we can really produce truly intelligent machines that are as intelligent as us, as humans, or maybe even more intelligent than us. And many of you probably attended my tutorial yesterday, so we already have a head start. And I'm going to talk about common sense, automating common sense reasoning. So let's look at the history of computing. So the ascendance of computing, so the computing revolution, you could say, started in the 1950s. The computers were invented in the 50s. By late 50s, the first computer was operational and companies were using them for various enterprise level operations for automating processes. And then computers became popular. They used to be really big, as you may have read. In fact, mainframes were really big. They occupied a whole building, you could say. Then the early 90s came, so that was the computing revolution that started the field of computer science. And then came the internet or the web revolution that most of you are really, the students are not old enough to, you were not even born then, probably. So that was around early 90s. So in 1969, the ARPANET was invented. ARPANET is the network that connected all the universities in the United States. So actually before email became accessible to everyone,
only the computer science departments had access to email. So when in 1985 I arrived as a graduate student in the United States, I actually had email. Nobody else did, only computer science students had it. And then of course, the computers got interconnected, and then in late 80s and early 90s, Sun Corporation made these computers and networked them, and their motto was, the network is the computer. Then the web came along, and the World Wide Web, and that really revolutionized how business is done. Everything was now being done online very soon, right? Then came, so that was called Web 1.0. So Web 1.0 was where you had static pages. So you could actually, those pages could be served and you could read them and get information. Then came what's called Web 2.0, where you could dynamically modify the web pages. And that actually gave rise to Facebook and Twitter and all these wonderful things that you all enjoy. So gave rise to social media. For social media, you really need to be able to modify your web pages dynamically. And then of course came smartphones around 2008, 2009. And Web 2.0 and smartphones got married, and now you can actually access everything on the smartphone itself. So that again led to smartphone becoming really popular, and I'm sure every one of you has a smartphone and you really cannot live without it. So when I was a child, I used to read these stories about this jinn whose life is in a parrot. If you kill the parrot, you actually kill the jinn. So our smartphone has become our extension. Our life is in the smartphone. If you use your smartphone, you really cannot live your life, right? It seems at least. So smartphone is really, so you can see the impact of computing and software on our life. You really cannot live without your smartphone. And everything is online. And then came the data revolution. So now everybody is using their smartphone. You're using various pieces of software, you're reading news on the smartphone, you're doing everything on the smartphone, but you're leaving a footprint. And so that data can actually be recorded and get analyzed. So that really led to the data revolution or the data science revolution. And that then led to AI. So we started with computer science. So the last 50 years you could say was the era of computing, but today is the era of data, you could say. So it's data science today. So this data can be captured, processed, mined, and put to beneficial uses by organizations. And then came cameras and sensors and Internet of Things, and you heard about smart cities. So more data coming in and to be analyzed. So that basically brought about the machine learning revolution and the data science revolution. So as I said, our hyper-connected world produces huge amount of data. Researchers realize that machine learning techniques can be applied to this data to learn and identify patterns. And as more powerful machines became possible, you could identify these patterns faster. And so that essentially brought in the popularity of machine learning. So there are three factors that led to this machine learning revolution, you could say. One is data being produced. Number two is new algorithms that people produce. So machine learning as a field has been around for more than 50 years. But there were certain advances in algorithms for machine learning that allow data to be analyzed and processed faster. And then came advances in hardware. So the biggest advance there was the invention of the GPU. So the GPU, which is also another name for graphical processing unit, was actually invented for speeding up video games. So a GPU really processes, so each pixel in your screen is mapped to a processor on the GPU. And so your screen can be rendered faster, so video games will run faster. But then people realized that machine learning algorithms really involve a lot of matrix manipulation. You could use GPUs. And so then people started using GPUs for learning these machine learning algorithms, and that really led to even faster learning and faster machine learning. So the confluence of these three factors has really resulted in resurgence of machine learning or AI. So what is artificial intelligence? And I think I asked you this question yesterday as well. So we have to start by asking, what is intelligence? So of course AI has been a goal of computer scientists ever since computers were invented. Right from the early 50s people started developing intelligent applications. So if you look at intelligence has two broad components. So one is learning knowledge, right? As intelligent it means we can look at patterns, observe our external world and generalize. So that's learning. If you automate that, it's called machine learning. And then once we learn from data or from observations, we capture the knowledge as rules. And if you apply these rules, then we are reasoning, we are doing reasoning. So we learn and we reason. If you automate the reasoning process, it's called automated reasoning. There are also other things like vision and speech processing and speech generation. But for the moment, we'll ignore those and we'll only focus on learning and reasoning. So AI has two components, machine learning and automated reasoning. Now, as you know, AI has been receiving a lot of attention, primarily because of this data revolution, a lot of data becoming available. And really, AI has become synonymous with machine learning today. So is AI really machine learning? AI deep learning? Is really deep learning? And the answer is actually AI is much more than machine learning or deep learning. It used to be that for the last 50 years, AI was synonymous with automated reasoning. But ever since this data revolution happened and machine learning algorithms can be applied, so machine learning and deep learning became really popular. And in fact, these algorithms can be used by almost every field, as we will discuss in a little bit. So if you look at the research in machine learning and automated reasoning, it started more than 50 years ago. I mean, ever since, as soon as, even more, even earlier, because the origins of a lot of the techniques is in mathematics, and of course mathematics has been around for thousands of years. So what is machine learning? Machine learning is really the technology of learning from examples. So given background knowledge, positive and negative examples of a concept, what is called training data, you learn the general rules that capture that concept. So you show to a child, examples of birds. So you tell them these are birds. For example, a parrot or whatever. And birds also fly, so the kid will learn that birds are flying objects. But there are also negative examples of what is not a bird, right? So as a child, you will learn that a plane is not a bird, for example. So from these observations, we generalize and we learn the concept of what is a bird. And there are various kinds of technologies, machine learning technologies. So if you automate this process, where you show a computer program pictures of birds, or feed the computer program pictures of birds, which are positive examples, and pictures of plane and chairs and tables or whatever, those are negative examples, then the program is able to figure out make a distinction between a bird and a plane and other objects. So if you show it a picture of another bird, then it will be able to tell you, well, this is a bird or this is not a bird. So that's machine learning. What is automated reasoning? Automated reasoning is the process of inferring new information. So given pieces of information, what are called axioms, you deduce new knowledge. So for example, if I tell you that all humans are mortal, and also tell you that Socrates is human, and since Socrates is a human and all humans are mortal, you can conclude Socrates is human, you can conclude that Socrates is mortal as well. Meaning that he is going to eventually die too, like all humans. So that's automated reasoning. If you can automatically deduce new information from information that you have. So machine learning research has a long history. If you look at techniques that are used in machine learning, such as Bayesian networks, Markov chains, least squares, probability theory, perceptrons, etc., they have been around since long time. In fact, Bayes' theorem was discovered in 1763 by a monk who did mathematics on the side. The concept of perceptron is basically a predecessor of neural networks, was discovered in 1957. And algorithms that neural network systems use, like back propagation for learning from training data, were discovered in the 70s and 80s. And in fact, the first international conference on machine learning was organized in 1983, long time ago, right? So machine learning has been around as a field for a long time. Today you have neural nets and deep learning and many innovations. So I explained to you the advances in software and hardware and availability of data that led to this machine learning revolution. That machine learning is almost a household word. So we researchers in AI are extremely happy because we have been doing this work for the last 30, 40 years. Or, for example, I have been working on AI for the last 30 years, since almost 1987. So it's a great joy to see that all of a sudden that what we were doing is immensely popular. Okay, what about automated reasoning? Automated reasoning also has a long history. Logic and inference procedures play an important role in automated reasoning, and it has been basically a concern of mathematicians for hundreds of years. So if you look at, so logic really is the formalization of thought process. So if you go back into history, you see that Aristotle wanted to formalize thought processes, what we call syllogism, and some of you may have actually studied this. Many of you probably studied Boolean algebra, and that was invented in 1850s by George Boole, who wrote a book called The Laws of Thought, and that gave rise to propositional logic. And then in 1870s, Gottlob Frege invented predicate logic and set theory. And then in 1930s, Herbrand, a French mathematician, figured out how to automatically prove theorems. And in 1960s, something that you might actually study in your AI course, the resolution principle was discovered. And that actually led to a revolution in automated reasoning. Today we really have advanced theorem proving systems, advanced logic-based programming languages, and advanced rule-based systems, advanced reductive systems, decision-making systems. And all of that is based in logic and automated reasoning. So, the goal of AI has been to produce automated systems that are at least as good as humans, if not better. But have we realized that dream is the question. Do we have machines that are better than us, or at least as good as us? But you could say, the answer really is no, but there are very specialized systems. So in the 80s, Deep Blue was designed by IBM, and Deep Blue was basically a chess playing program that could actually beat the world chess champion Garry Kasparov. And then about 10 years ago maybe, IBM designed another program called Watson. Watson won a quiz show, very difficult quiz show, and if you are interested, you should go and Google Watson and Jeopardy. You can actually watch the episodes. Really hard problems in a quiz show, and Watson was able to beat so this program Jeopardy has been going on for more than 40 years. Watson was able to beat the two best players who won the largest amount of money on Watson. And then a few years ago, this company which was actually called AlphaGo, which was actually acquired by Google recently, managed to beat the world Go champion. So Go is a game that is more complex than chess. So researchers thought that machine can beat a chess player, a chess world champion, but can never beat the world Go champion. But it so happens that by using, in fact, machine learning in this case, a program was able to learn all the moves, and it managed to actually beat the world Go champion. And also it has self-driving cars. I put quotes around self-driving cars because they really truly are not there yet. They really are not truly self-driving. So the question is, have we really truly realized a truly intelligent systems? And I would say that there are lots of applications and there's a lot of excitement, and almost every field can use AI, but we still have not reached the goal of designing machines that are as good as us. And there have been a lot of false starts. So after the discovery of perceptrons, stories appeared in the news media that human-like machines are just around the corner. And then expectations from AI were so high in the 70s that people said that, oh, we'll have machines. In the 70s, people said there'll be machines in 30 years that are better than humans. Well, 30 years came and passed, and that's 20 years ago, and there were no machines that are better than humans when it comes to intelligent behavior. So that actually led to AI becoming unpopular. So the government stopped investing in AI, and that actually is known as the AI winter. So when we as old-time AI researchers see this excitement, we worry that the field of AI is maybe being oversold, and that more promises are being made that cannot be kept. And really, inability to build these fully intelligent systems has led to this vacillation between using automated reasoning-based techniques or using statistical or machine learning-based techniques. So the pendulum has been swinging back and forth. And today the pendulum is actually on the side of machine learning, you could say. So, so if you really want to build a truly intelligent system, we should be able to build a system that can not only just learn but also reason. And unfortunately, the entire focus today is on machine learning. And AI, when you talk about AI, people really take it to mean deep learning. And you could argue that automated reasoning based techniques have been researched, but there is more possibilities left for research in machine learning, and that's why people are focused on machine learning. But machine learning and deep learning really are very good at recognizing patterns. And that's the limitation as well. So they can recognize, for example, faces very well. They can in fact outperform humans for detecting tumors from medical images, for example, MRI scans. You can train a system that can recognize a cancerous tumor much better than a human can. For game playing also, where there are patterns involved, machine learning can really beat humans too. Language translation is another one, where you can automatically, you essentially give hundreds of thousands of examples of sentences in, say, English, and they're mapping to Hindi, and the machine can learn the association, and it can actually translate an arbitrary sentence in English to Hindi or vice versa. And all these technologies like Google Translate, etc., rely on that. So when machine learning actually applies, it does a very good job. Now I can give you a brief primer on machine learning that's based on neural networks. But the idea is that if you look at a neural network, it's basically got layers of nodes that are connected to other layers. And the whole idea in training your system is to actually learn the weights on these, I don't know, my cursor is not well. Can you see the cursor? No. So if you look at the diagram, here, so this is the input layer and that's the output layer. On the input layer, you will feed, say, a picture of a cat, and you're trying to train your system to recognize a cat. And the whole process of training is to figure out weights on these edges. And really, a machine learning system or a neural net is a universal function approximator. And you learn the weights on the network iteratively. And so these are the weights that are shown over here. These are your input nodes. You have some kind of weights, and there is a function that computes an output based on these weights and based on the input coming in. These weights have to be learned, and that's the training process. Okay. So what training does is really come up with a function that approximates the mapping between the picture of a cat and the word yes, and a picture of a non-cat and the word no. So what you're really doing is learning a function. So it's nothing but a function, universal function approximator. You're really learning a function. But when it comes to learning patterns, really nobody can beat neural networks. However, there are many limitations of neural networks and machine learning. So for each application, you have to train it extensively. If you want to design a machine learning system that can recognize cats, you have to give it thousands of pictures of cats. And you cannot really ask the machine learning system, the model that you train, that you obtain by training on the pictures of cats. If you ask the question, why is this a cat, it won't be able to tell you. Whereas we humans can tell you, right? If I look at a cat, you say, why do you say it's a cat? You say, well, it's got whiskers, it has the ears of certain shape, it has a certain profile, therefore it is a cat. But a machine learning system cannot tell you. It's computationally very expensive, it takes huge amount of time to train. So there are many, many issues as well. There are even more issues that, for example, if you look at this stop sign, so the stop sign is ubiquitous in, for example, USA, where if there is no traffic light, there will be a stop sign to tell the driver to stop. But what researchers found is that if you put some tape, so you see that the tape there, love and hate, just with white tape that was put over there, then the machine learning system, self-driving cars could not actually recognize the stop sign. But no human will have difficulty in recognizing that that's a stop sign, right? So really, self-driving cars, you should really be careful with driving a automatic car that drives itself. Because if you tamper especially if there is some dirt on the stop sign, it won't be able to recognize it, then you are in trouble. Your car will not stop, right? So you can fool a machine learning system. Here's another very good example. So you have a picture of a panda, and what researchers found is that if you mix it with this another picture, on Photoshop, you kind of merge the two pictures. So this is like a white noise picture, just bunch of pixels, random pixels. So you can see this is the resulting picture. Now no human will be confused that this is not a panda, right? You still see it's a panda. But the machine learning system got confused and it thought it's a gibbon, another animal. This is even worse. So this is picture of a school bus, and you mix it with white noise. This is the picture that you get. If you train a machine learning system on pictures of buses, for this picture it was able to correctly recognize that this is a school bus or this is a bus. But when you mix it with this white noise, then it got confused and said it's an ostrich. So you see the problem that machine learning systems are only as good as the training data, and you can easily confuse them. So if a hacker, for example, realizes that a computer system is using machine learning for recognizing certain things, they can easily fool them. Once they figure out the algorithm that the machine learning system is using. So that's a big challenge, and that's also a big area of research called adversarial machine learning. How do you stop these attacks? How do you improve these machine learning, the algorithms, that you don't make these mistakes? And so that's why you organize these kind of conferences where you can present new results and avoid being confused, avoid machine learning systems being confused. So here's a quote from one of the well-known persons in AI and tech, the CEO of Allen Institute of Artificial Intelligence, who says, so he's basically saying, well, we all get excited that there are programs that can beat the chess champion. So he says, yet the overblown claims about the impressive success of AlphaGo, AlphaGo is the program that beat the world Go champion, are really the case of a person climbing to the top of the tree and shouting, I am on my way to the moon. So there are a lot of limitations that still machine learning has, but when it applies, it really works very well. So it's hugely successful when it applies. So if it is applicable to a situation, it is really amazing technology. So, and in fact, it is useful for every organization. So, if you look at any organization, any field, every field or organization has huge amount of data it generates. So, especially with all these sensors and computing being used and cameras and all these things, every field, every organization has big questions that it wants to ask. Right? There are open problems that every field wants to solve, and machine learning and data science can really help finding these answers and solving these problems. So for example, an organization may want to know which employee, they're always interested in reducing the turnover of employees. So for example, you can apply machine learning to figure out which employee will leave the organization in the next 1 year. So for example, in a hospital, all these women in labor come in about to deliver a child. You can apply machine learning technology to figure out which patient coming in will need a C-section and which one will not. You can also use it, for example, for various banking operations. So for example, you can analyze all the past loan data, whether a person was given a loan or not given a loan, and a machine learning system can learn all that pattern. And when a new customer comes and asks for a loan, you can use the machine learning system. And the machine learning system can simulate a bank and say, yes, you will get a loan, or say, no, you cannot get a loan. So they're really very interesting applications, and that's why everybody is interested that if I have the data, I can detect the patterns and learn something from it. However, people also talk about AI taking over the world, but that's at least not going to happen in the near future, because again, machine learning really is just a universal function approximator. It's learning a function. Now let's talk about automated reasoning. So automated reasoning has also had its ups and downs. So there are many problems that are somewhat technical in nature, so I'm not going to go into those. But the biggest problem that classical logic has, and we talked about it yesterday, is monotonicity. That once you derive a result, it stays on forever. Once you prove a theorem, it will stay on forever. It never becomes false again, right? So Pythagoras' theorem is true forever. But in day-to-day life, that's not the case. As we learn new information, we withdraw our old conclusions and we make new conclusions. So we need a different kind of logic. And again, you heard me talk about answer set programming and ASP as the new kind of logic that we can use. So we really need both learning and reasoning. And if we can overcome this problem of machines being able to do common sense reasoning, and they already are very good at learning, then we can really build extremely smart systems. Systems that can maybe even outperform us, robots that act like humans, human-like chatbots to help customers, truly autonomous cars and trucks. So, but in order to do that, so what's the road forward, basically? So I kind of talked about machine learning, I talked about automated reasoning. How do we go, where do we go from here? So what my vision is, and vision of a lot of people as well, that we really would like to build systems that are as good as us. So for me, if I can reach that goal, then we have really achieved a lot. So that goes by the name of AGI, or what's called artificial general intelligence. Building machines that are as intelligent as us human beings. ASI is artificial super intelligence, where you build machines that are much smarter than us. Now, you could say that some of the machine learning systems are smarter than us. So for example, there are face recognition programs that, so there was a story where in China, in this one city, they have cameras everywhere, and any random person who's in their database is walking around in the city. Then there was actually a reporter who went there from the United States, and they challenged the reporter that you go around the city, and so and they took his picture and his identifying information. Within 6 minutes, they tracked him down at a train station. So these machine learning systems are really good at face recognition, so they're better than us. But somehow we really get shocked that these systems can have this ability. But if you look at the power of machines, I mean, machines have been doing weather prediction much better than us for the last 10-20 years. They can predict the weather, for tomorrow. We humans cannot do that. But we really don't get surprised by that. But when we see a machine can recognize a face much better than us, or detect a tumor, we really get, you could say almost, we're afraid that machines are going to take over our jobs, take over our role in society. But that's far away. I mean, it's again, all these machine learning applications are really narrow applications. So our goal should be to build systems. So outside of detecting face, this system cannot really do anything. It cannot, for example, tell you what time does my train depart from the train station. All it can do is tell you, this person is XYZ. But if it looks at a face, it can recognize it. That's it, right? So extremely limited. Whereas you and I are very sophisticated. Not only we can recognize faces, but we can also do many other things. Now you can think of a machine learning system really as, so why can it do better than us? And the reason is that if you look at a human, then our capacity is limited. So maybe we can recognize 200 people or 300 people, right? That's what those are the people in your social circle. Maybe there are people who recognize 500, right? And how do we recognize people? Again, we pattern match. But you can think of a machine-based system that's a perfect recognizer of faces. So it can recognize everybody, right? If I had really supreme pattern recognition capabilities, maybe I can recognize everybody. That's what really a machine learning system is. So anyway, our goal should be to build machines that are as good as us. But if we want to build those machines, we need to simulate the human reasoning process. We need to be able to perform common sense reasoning. So So for that, we need a specialized logic called ASP, and if you're in my tutorial, you already learned a little bit about ASP. If we can code all human knowledge in ASP, rather than trying to learn it from scratch, then it's possible that we can basically automate this learning of common sense knowledge, and we can maybe build a system very fast that is as good as us. So that's one of the goals of research, including my research, to not only automate common sense reasoning, but to be able to quickly learn common sense reasoning as well from the text or from the textbooks and books and other things. So I'm going to not bore you with the details. So just to tell you quickly what common sense reasoning is, and then I'll get to some of the applications, and then I will conclude. So what is common sense reasoning? We humans use what's called default reasoning. Again, those who came to my tutorial yesterday have the benefit of already knowing what it is. So if I, for example, tell you that Tweety is a bird, and I ask you, does Tweety fly? You're going to say, yes, Tweety flies. But then if I tell you that Tweety is also a penguin, then you will withdraw your conclusion about Tweety. Tweety is flying with a Tweety, and you will say, well, no, Tweety does not fly. That's how we operate, essentially. We jump to conclusions, and then as we learn more information, we refine our inference or the knowledge that we have learned. So first we concluded that Tweety flies, then we refined it, we say, no, Tweety doesn't fly because it's a penguin. Okay? So that's what common sense reasoning is, and we employ that every day. So just let me tell you some of the projects that we are doing in automating common sense reasoning. So one of the systems that we have built tries to simulate a cardiologist. So a cardiologist who treats congestive heart failure. So congestive heart failure is treated using guidelines. So there are something like 100-page guidelines that have a bunch of rules that cardiologists are trained on. So we built a system that where we coded each of the rules in this specialized logic that I called answer set programming. And then we're able to recommend treatment for patients based on their electronic health record that has their blood pressure and their potassium level and all the other 30 odd factors that you record for each patient. And our system was able to actually outperform the cardiologist. It would actually recommend a treatment. It will not miss cases where a cardiologist will miss a case, our system will not. We also are building systems based on common sense reasoning that can learn from a textbook, the knowledge from a textbook, and you can ask questions of it. We also have projects on natural language understanding. So for example, when we read a natural language passage, like if you take an exam and you're given a passage and you have to answer a question, can I automate that process? But when you read the passage, there is a lot of information that is brought in that you already know, right? That there is additional common sense knowledge that you bring in answering questions on a passage. Unfortunately, when you use machine learning for answering questions, it does not have access to this common sense knowledge. So what we really need to do is to build systems that can analyze the passage, bring in the common sense knowledge, and then be able to answer questions. So that's what we're doing in a project that we call Casper. So we code the natural language story, knowledge in a story in ASP, our specialized logic, and then we code common sense knowledge. For example, if you see the word rabbit, immediately you know that rabbit is an animal. It has possibly white fur, furry skin. It has 2 eyes. It has nostrils. It can run very fast. All that information is not in the story. So we bring in that knowledge, and now when you ask a question, it can actually answer the question. So in the Casper project, you can, for example, give this kind of passage. About American Broadcasting Company is an American commercial broadcast television network that is owned by Disney. And then you can ask questions like, what company owns the American Broadcasting Corporation, American Broadcasting Company? And it actually give you all the correct answers. There are 3 answers there. It will give all of them. Or you give another story about football play, and you can ask the system questions. So it's almost like if you took the CAT exam, when you have passages and you have to answer questions. I should be able to build an automatic system that can answer these questions against the passage. We're also doing projects on, so again, another application of common sense reasoning. So one problem with AI or machine learning is that it cannot tell you if it recognizes that a picture of an animal as picture of a panda. If you ask that system, why is this a panda? It cannot really give you an answer. So we're working on a project where it will give you an explanation. So you train your system using a machine learning algorithm, you come up with a model, you feed the model to our system, and the system will actually give you the logic that the model captures. So for example, we applied it to a data set from University of California, Irvine, the UCI data set that many of you may be familiar with, on who makes more than $50,000. So there's this huge data set where for each person it gives their age, their gender, their education level, and then it tells their salary. Your goal is to predict, given a new person, whether they will make more than $50,000 or less than $50,000. So we trained a neural network on that data, and then we fed it to our system called Fold, and it came up with these rules. So these are rules in logic. And basically the first rule, for example, says that A is an individual who makes more than 50,000 if the person is married and education is at least a bachelor's. And there are a whole bunch, so it came up with 6 rules. And you can see that these rules actually capture what we already know, that married people make more money and men make more money than women. So these are some of the biases that you can discover in your data by using our system. And so this field of machine learning is called explainable AI. This is actually a very hard field these days. And Europeans, for example, have made a law called GDPR, which stands for General Data Privacy Rule. And basically, Europeans have said that if you use a machine learning system for making a decision, for example, giving a loan or denying a loan, then you have to explain your decision. So to explain that decision, you have to really understand the logic that is captured by the model. And so that's why explainable AI. So again, just let me conclude. So takeaway is that AI technologies, both learning and reasoning, have been developed through research that has been done over the past 50 plus years. Machine learning and deep learning technologies have become prominent as more data and computing power has become available to make them extremely useful. Machine learning and automated reasoning have tremendous potential for industry and innovative applications are possible. However, dream of human-like intelligence has not been realized yet. And what is really needed is to model somehow common sense reasoning and answer set programming that you learned from my tutorial yesterday can make the realization of that dream possible. There are a whole bunch of books that you can read about common sense reasoning that you can, go and study. And that's my talk. And thank you very much. Any questions?
Thank you very much, sir, for sharing your deep knowledge with all of us. Finally, as an appreciation for our honorable chief guest and guest of honor, I would like to invite our respected chairman, sir, and managing director, Shri Shriyansh Jain ji, to offer memento to our honorable guest. First, I would request respected managing director, Shri Shriyansh Jain ji, to present memento to our guest of honor, Dr. Gopal Gupta ji. our chief guest, Honorable Vice Chancellor, gratitude is our ability to see the grace of God. It inspires happiness and carries divine influence. So, to acknowledge the valuable presence and contribution of everyone, I would request our Director General, Core SM, Professor Dr. Om Prakash Soniji, a dynamic and magnetic personality, to deliver a vote of thanks. Please, sir.
Good afternoon, Honorable Chairman sir, the chief guest, distinguished guest, and the academic galaxy present in this hall, the future vice students. It's indeed a great honor for me to have been given this opportunity to propose a vote of thanks. I really feel honored, very important job. No event can ever be successful without the contribution of everyone whosoever is associated, not understanding directly or otherwise. First and foremost, our Vice Chancellor, grateful to you, sir. I know I have been there for you and Professor Dr. Gupta spoke to you. Despite your ingenuity, you made it for us. We are indeed grateful. It is not that our Vice Chancellor is here with us today. For all our needs, whenever we have approached, believe me, one day I walked into his house during the lunch and he accepted. Thank you very much. Dr. Gopal Gupta, no words shall be what favor he has done to be with us. And alongside you, sir, I must thank Mrs. Gupta for being with us. Thank you, ma'am. Your presentation went up very well. It's not today what you shared with the students yesterday. Actually, when you see the audience and when you see the students, it's blueprints. It is because of the tutorial students. We are really grateful to you for coming and being with us. Thank you very much, sir. You have added the rainbow color to our shows. I also take this opportunity to acknowledge so many academicians of global order being with us, and Mrs. Ila Gupta, Professor Dr. Ila Gupta, Department of Architecture. I have to thank you, ma'am. Dr. Dev Sarkar, so kind of you, sir. We keep getting a lot of motivation guidance from you. Professor Nishya Verma, IIT Kanpur. Ansari sir, who is our own faculty past years and today is with Gautam Buddha University. I shall also recall Dr. Narsingh Das sir is here and so Dr. Thari sir. So indeed very grateful to you, sir. Our gratitude to all of you, sir, that you have come and are with us. An organization of this event cannot be organized unless you have a very distant looking vision and will to turn back into reality. Thank you, sir. Our chairman is always for these things. Believe you me, he always keeps things at least 20 years ahead. And today when we are having this conference, actually it is his vision. We are trying to turn into reality. Energetic young man and who is shoulder to shoulder with us always, Shanji. And whenever we have requested him, whenever he is MP of so many organizations, notwithstanding, he is always with us whenever we want to. Grateful to you, sir. A leader in two sense, leading from the front, taking the team along, finding only the positive in a person. I have never seen anything negative in anybody, and motivating everyone around. Professor Dr. S.P. Gupta. That's a great thing. In military parlance, they call leadership in two sense. That you take the best of everybody and fusion. Thank you very much, sir. Presence of such globally recognized faces from academic world here. Believe you me all, ladies and gentlemen, Dr. Gupta is the person behind it. Leadership apart, it is a team which also makes a great difference to success of any. Our deans, Dr. D.V. Gupta, Dr. V.K. Singh, Dean Academic BMC, who is also the organizing secretary, and I would also like to talk about Siddharth. They have really worked their way. They have toiled beyond the call of duty, and it is because of that they are so successful. Thank you very much to all of you. There are certain people who are not seen in front, but their contribution makes the difference. The academic, the technical, and the administrative teams, ably led by our registrar gurus, that is Ajay Sharma and Ranit Kishore. You have done a very good job. Thank you very much. The entire system beautifully well. Our esteemed regulatory authorities, All India Council of Technical Education, and Uttarakhand Technical University, especially Technical Education Quality Improvement Program, that is taken, have really been with us, and we acknowledge their support for this. Thanks to them. Press makes a lot of difference. Makes people aware around that an event of this magnitude is happening in Rome. And we thank them for being so kind and taking the message across. We shall now have national anthem, and after the national anthem, I shall request delegates to move for lunch. But before that, I would like to thank all our students. I'm sure you have learned a lot from this. But an opportunity like this doesn't come easily. And it is only an institution like CORE where you have this opportunity. So you are very lucky. Actually, instead of thanking, you should be thanking the institution, but that's your alma mater, right? So now I request all of you to please rise. We go on national. Finally, please.
अधिनायक जय हे भारत भाग्य विधाता, पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा, विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा, तब शुभ नामे जागे, तब